So a trigonometric ratio, it's the ratio of the lengths of two sides of a right triangle. You can only use trigonometric ratios with right triangles, which is what we've been working with. You're going to use the ratios to help you find the measure of an unknown side or an acute angle eventually. So we're going to do a lot of work with trig ratios. Okay? The first trig ratio. Now, some of you may say, where does this come from? Well, guess what? Tomorrow I'm going to show you on the unit circle where it comes from. So there's something to look forward to. Okay? Tangent is a trig ratio. Look on your 84s. If you have an 84 calculator, if not, just look at mine. Look at these buttons right here. Sine, cosine, tan. You use them so much, they have their own calculator button. Now, on the Inspire, I do know how to get to them. You see the word trig right here? Push the word trig. It's right here, trig. Okay, and there's tangent. Shh. So if you push enter, I'm going to show you how to do this, but there's something on here I cannot figure out how to change. It has to be in degree mode, and I believe it's in radian mode right now, and I can't figure out how to switch it. But I'll show you that later. Don't worry about that. Okay. Tangent is the first ratio we're going to work with. So this symbol right here is just a Greek symbol from the Greek alphabet. It stands for theta. You might see it like that in the book. It just means a given angle measure. You're going to have a measure in there. So it just means a given angle. The tangent of theta. And they use it sometimes for just like the general formulas. Okay? It equals the opposite, I'm going to abbreviate opposite with OPP, opposite leg over the adjacent leg. Now stay with me, I'm going to explain all this, don't worry. A right triangle here. Let's say that this is theta right here. I don't know the degree measure of theta. I'm just saying that's theta. Okay? Now, if I had to write up the tangent ratio of theta, I would look for the opposite leg from this angle. Where's the opposite leg? Right here, right? Yeah? And it would be some number. It would be some number. And then where's the adjacent leg? Right here, right? It would also be some number. What's this part called right here? That's going to be referred to the hypotenuse. We're not using that today. We're just using the opposite and the adjacent leg today. Now, these ratios were discovered by, I don't know who, some mathematician somewhere. But if you have a right triangle, any size right triangle, hey, listen up. It could be a right triangle the size of this room. Or it could be this tiny right triangle. But I'm being enthusiastic. If this angle measure was 53 degrees on my paper here, or in that giant right triangle, if that one angle was 53 degrees, the ratio of the opposite leg over the adjacent leg would be the same number. Let that sink in for a second. Any size right triangle, if you're looking at a 53-degree angle of any size, but the angle is 53 degrees, the opposite leg divided by the adjacent leg is going to be the same number. On that note, go to page 925 in your book.
Page 925.
Yeah.
29. Let me turn your seat.
So the beauty of this page right here is, you cannot come to school tomorrow and say, I couldn't do my homework because I didn't have a graphing calculator. Because you can, because all the ratios are on this page. And they're also all programmed in the calculator. So, remember what I was talking about, that triangle that's the size of this room? Or the triangle on my paper? Let's say the one angle in that triangle was 53 degrees. If I take its opposite side and divide it by its adjacent side, it's going to be the number 1.32, always. There's the tangent of 53 degrees. See it?
Do we have to remember anything?
No.
Oh, thank God.
Well, some of the main ones you might.
Wait, so you round side?
So we would round. We're not going to use all of those, but we would probably round to tenth or hundredths.
Really random question.
Yes.
Can there be a right triangle that's 90 degrees, 90 degrees, 89 degrees, and 1 degree?
Probably. Of course. It would be tiny, 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 tiny.
Okay, because I was just thinking about it.
Okay. So, yes.
What is a sine and cosine?
We're getting to that tomorrow. There's 3 trig ratios. We're doing tangent first. Now, go to, if you have an 84, go to the 84. You could try it on this too. I don't know. Turn it on. Push the tangent button.
Where's that?
Tan.
Tan? Okay, check.
53.
53. Check.
Enter.
Enter.
It's the same number that was in the book. All of those trig ratios are in the book, in the calculator. Now, wait, just wait. If you didn't get the right number, you have to change it from radian mode to degree mode. So you go to this mode button right here. Mode is right here.
I'm not on that.
Okay, and then you go over to degree.
Okay. Where's that? Where's degree?
Right here. Now, this is what I cannot figure out how to do on the Inspire. So maybe some smarty pants people can figure it out. So, did you now, once you set it, I can figure out how to set it, but then it doesn't work when I go back and find the tangent. Try it, Justin. Did it work? I knew Justin would figure it out. But you know what? You can do it on your phone if you have a phone and a fancy calculator on your phone. Let me show you.
I just turned it off.
Just second quit. Just the second button and the mode button, it says quit. Okay, now look, you guys. Shh. I know I have an iPhone, but I'm guessing other phones. You know how it looks like? It looks like this. If you turn it, let me see if I can get a better picture. Now, oh, it's not going to work, but this has to say degree on your phone. It has to say degree. And if it doesn't, there's this little button right here that says RAD down here in the bottom left. Just push it and it'll switch to degree. But the tricky thing with the iPhone is you have to put the degree measure in first and then push the tangent button. Okay, so,
My phone already has 10 on it.
yeah, okay, so we'll figure that out. Let's do a few problems together, okay? Let's just do a few problems together. All right, we're going to use this tangent ratio to help us find side lengths. Shh, let's go, let's go. Find the value of x, round to the nearest tenth. Notice you have a right triangle. I don't have the hypotenuse, so I can't find this side, but we learned trig ratios so that we can find this side. We can't do it with 30, 60, 90. We can't do it with 45, 45, 90. We just have a funky angle measure and 2 legs. So I can use the trig ratio. So what I do is I set it up just like this. The tangent of theta, but they gave me theta, it's what degree measure? 17. So the tangent of 17 is just a number on my calculator, right? Just stay with me. Is equal to the ratio of the opposite, which is what? 9, over the adjacent, which is what? X. Now this is just a proportion because remember this is a number on your calculator. It's already programmed. Okay? So you go to your calculator and you push whichever calculator you want to use, the tangent of 17. If you don't have a calculator, where can you get that number? The back of your book, your phone, okay, whatever. So we're only going to go to the tenths place. So we're going to write it as 0.3. 0.3. Actually, let's go to the hundredths just for the heck of it. So it'd be 0.31. This number is 0.31. Yeah? Because it's already programmed in here. Any 17-degree angle, any 17 degree is opposite, right? Yeah. Okay. Now I cross multiply because I can put that over 1 and I can cross multiply. 9 equals 0.31x. Divide by 0.31. You know,
9. Wait, I've got to get this. 9 equals.
let's round it to the tenth, so it's just going to be 29.0. Yes? You know, you don't have to do all this work when you have a proportion. I don't know how many people know that. All you got to do is multiply the two numbers together you have and divide by that third number. That's it. You don't even have to set it up. 1 times 9 divided by 0.31. That's it. But if you can't remember that, then cross multiply and set it up. Okay? All right, let's do another one. Take a look at this. I have 63 degrees here, or 61, excuse me. So I'm going to write, I have the opposite and I have the adjacent, so I'm going to write the tangent of 61 is equal to what? The opposite, 22 over x. This is just a number. Get it off your calculator or your book or whatever. Okay? Here's what I see people doing. Please don't do this. I see people wanting to divide by 61. You cannot split those up. It's not. It's a number. It's just a number. So you just get it off your calculator. Okay? And it is what? What is it? Let's look at it. Let's see what we want to round to here. Tangent of 61. Let's do 1.8. If what?
We just decided I'd rather do like all of it.
Have fun. I wouldn't get mad, no, but okay. Now look, put this over 1, cross multiply, so you just do 22 times 1 divided by 1.8. If you can't see that, set it up.
2.
It's 12.2, so let's round to the 10th. 12.22222, right?
It's too nice.
That's not what I got. Really?
You got the right number.
Yeah. Oh,
How'd you learn that?
I don't know. Oh, it's 22. Yeah, 12.2222222.
Yeah, but what you did was too nice.
Oh, as a
What is
fraction.
the exclamation point?
You can write it as a fraction if you want.
It
Okay.
makes my head feel better.
That's fine.
It's very good.
Okay.
Or you can write it.
What is the exclamation point doing that?
Oh, that's factorial. Do this one, you guys, on your own, real quick. Do this one. Here's your angle. Here's your opposite. Here's your adjacent. So be careful with that. So do that one on your own.
Okay, here we go.
Tenths. Do the tenths. Man, you want to borrow my reading glasses, Jill?
And she wears
Okay, here we go.
Do it as 1.5, please. Your answer will, it's fine. Your answer will be slightly different if you used a different rounding. Right, you got it? Cool? Grace, no?
No, I got it right.
Okay. Uh-oh. What'd you get for the tangent of 56, Sarah?
They did the opposite. They switched the legs.
Oh, yeah, you got to be careful with the legs.
No,
Yeah.
it's not.
Oh, okay. All right. What happened, Sabina?
I did a round and I got a very different number.
What'd you get? What'd you use? You used the whole number?
Yeah.
Okay. Tangent of 56 times 13. Is that what you got?
No, I did wrong. Never mind.
Okay. So these are really handy in surveying, architecture, all that kind of stuff. So we're just going to do a little simple application problem here. Ready? Find the height of the flagpole. They have these little, have you ever seen those surveyors out in the middle of the road and they've got these little things that like go up and down that they look through? They're actually using, it's called an altimeter or something like that. They're using ratios, trig ratios. That's what they're doing to find the height of stuff. So here's my given angle. This is the opposite and this is the adjacent. So let's find out how high that flagpole is. Tangent of 65 equals x over 24. Tangent of 65 is just a number. I get off the calculator. Let's round it to the tenths, so we'll do 2.1.
Oh, I did do that. Ah.
Cross multiply. Tangent of 65 is 2.1. Did you guys get that?
4 equals x.
X equals 50.4. What? Don't leave it naked. Okay, let's have some fun on this last problem. You ready? All right. It says use a 30, 60, 90 triangle and a 45, 45, 90 triangle. The leg and the shortest leg for the triangle is 1. Find the tangent of the non-right angles. It's not that bad. Let's just draw a 30, 60, 90 triangle first. Something like that. It tells me the leg and the shortest leg. So the shortest leg here is 1. Let's label this. I'm going to label this A, B, and C. If this is the shortest leg, and this is a 30, 60, 90 triangle, which angle is 30 degrees? A. Has to be opposite the shortest leg, right? So then this one's 60. Okay, we're good with that. Sort of. We can go further. You learned in the last quiz that if this is a 30, 60, 90, and this is the shortest leg, how long is the hypotenuse? 2. You double it. You double the shortest leg, right? You double the shortest leg. And 1 times the square root of 3, which is just the square root of 3. So we have that labeled. Now let's do the 45, 45, 90 triangle. The leg is 1, so this is 1 and this is 1. I don't really need that. You can write it if you want. It's square root of 2. Okay, D, E, F, I'm labeling that. Okay, let's do what they're asking us now. It says find the tangent of the non-right angles. So let's start with this one. This one's easier. The non-right angles are both 45, right? So I just need to do one of them. So I'm going to say, okay, the tangent of 45 degrees, do not touch your calculator. You don't need your calculator to do this because we have the numbers that we need. We can do it without the calculator. It's equal to the opposite over the adjacent, which is 1 over 1. So, no, what's 1 divided by 1? 1. Now, if you really want to test what we did, you can go and try what the tangent of 45 is. What is it?
1. It's a whole number.
Okay? So see, we could do that because we have both of these numbers, we can find the tangent, right? Okay, let's do this now. We're going to do it for A and B here. The tangent of A, which is 30 degrees, excuse me, let's just write 30 degrees here. The tangent of 30 degrees is the opposite, which is 1, over the square root of 3. Do not touch your calculator right now. We know how to simplify this. How do we simplify this? Yes, Eve?
Times it by the square root of 3 over the square root of 3.
Equals the square root of 3 over 3, correct?
Yeah. Which is what?
No, it's not. Okay, now what I want you to do is I do want you to get your calculator, and I want you to just do the square root of 3 divided by 3. Oh, wait, that's not what it is. Second square root of 3 divided by 3. So, write that down. It's approximately 0.577, yes?
I got 1, 2. Okay. How? Because you
Now use the tangent button and see what the tangent of 30 is. Look at that, it's the same thing.
You know.
Almost done, we have to do 60 degrees. Ready? Let's do 60 degrees. The tangent of 60 degrees is equal to the square root of 3 divided by 1, opposite over adjacent, which equals the square root of 3. Let's find out what the square root of 3 is, just for fun, because we're in math class.
This is so much fun.
Okay? And then, if I put in the tangent of 60, what do you think you're going to get? The same number. Okay?